GIS is Geographical Information Systems. I'm Damien Mansell, an Associate Professor of GIS at the University of Exeter. I'm here to explain what this means. What can we do with a GIS? So, the geography, the geographical, that's the study of a physical feature of the Earth and its atmosphere and human activity and features and areas on it. The information is not just the location of where that is happening, but it includes the what, the when, the why, and the how. And it's the system, the tool, the software that allows us to combine all these different spatial data sets to detect patterns, answer questions, infer insights in our spatial analysis. GIS is also known as a Geographical Information Science because GIS is the technology at the heart of our spatial analysis, but it's also a discipline in its own right. The science offers us how we represent the real world, how we capture the data, how we organize it, and how we analyze it. GIS allows us to think of the world spatially at a global scale or a local scale, thinking about processes using data from satellites to those collected in the field or on your phone. It allows us to connect people working in the office to field workers who are out on operations. We use it in different sectors from utilities, military, planning, and in governance for making decisions. We're currently going through a geospatial revolution where new people, new sectors, new disciplines are embracing GIS and the power of geographical thinking about the science of where. To explain further what we can do with GIS, I'm going to run through a very famous example from John Snow's 1854 cholera map. It was at a time when there was a cholera outbreak in Soho, London, and in 3 days over 120 people died from this disease. John Snow used the outbreak to prove his theory about the spread of cholera. He famously plotted the locations of deaths on a map, as you can see here. And he found that they clustered around a pump at Broad Street. He suggested the pump be taken out of service, the handle was removed, and the epidemic came to an end, saving many lives. He used this spatial location information to formulate his theory about the spread of cholera by dirty water. And this analysis is famous as it's often considered to be the first epidemiological analysis of any disease, trying to understand the spread of cases by factoring in the environment. It's the first geographical analysis of disease data, putting points on a map and looking for relationships, looking and detecting spatial patterns. John Snow carried on his analysis further and was able to identify the isolated cause of the infection. A child had been taken ill with cholera and its nappies had been cleaned in the water that was subsequently tipped into a cesspool very close to Broad Street well. These days we can look at this example and apply similar techniques to detect patterns and show stories and speak about our spatial data, as well as new and advanced techniques and ways to showcase the data itself. We've got the John Snow map here with a proportional symbology map, and you can see the same sort of clustering. Rather than black lines on a map, we can do proportional symbology. We can have interactive web maps, and we can use different ways to represent the data to show this clustering. We can offer new techniques, new analysis, big data, and indeed that's what we have done during the most recent pandemic. The most famous viral map here, looking at from the Johns Hopkins University of COVID cases around the world. Interactive map allowing users to get information from different locations around the world. So GIS has been a tool to help us solve and understand the spread of disease and in this case as well vaccinations, the spread of vaccinations. But we can apply spatial analysis tools in many different areas of geographical research, in sectors, in business, and in anything we do, because everything happens somewhere. And that is the power of GIS.